Did you know that a tiny change made during aircraft maintenance can potentially create a serious safety risk? Something as simple as changing a wire route, installing the wrong fastener, or altering a protective component can affect the aircraft's original safety design. This is where CDCCL comes in. CDCCL stands for Critical Design Configuration Control Limitation. These are specific design features, configurations, or maintenance requirements that must be preserved throughout the aircraft's operational life. CDCCLs are particularly important for preventing ignition sources from developing in areas where flammable fuel vapors may be present. Aircraft fuel tanks can contain flammable fuel-air mixtures. Engineers therefore design the aircraft with multiple features to prevent ignition. These features can include electrical separation, bonding and grounding, wire routing, component locations, insulation, shielding, and specific installation requirements. A CDCCL identifies configurations that are so important to the aircraft's safety that they must not be changed without following the approved maintenance data. Here's a simple example. Imagine electrical wiring installed near a fuel tank. The original design specifies a particular routing and separation distance from other wires or components. During maintenance, a technician might be tempted to move the wiring slightly because the original route is difficult to access. But that small change could reduce the design separation or introduce a potential ignition risk. If the routing is controlled by a CDCCL, the technician must maintain the specified configuration and use the applicable approved maintenance procedure. Another example involves fasteners and hardware. Aircraft manufacturers may specify particular fasteners, materials, installation methods, torque values, or locking methods for safety-critical areas. Replacing a specified component with a visually similar part does not automatically make it acceptable. The approved maintenance data must always be followed. Bonding and grounding are another important area. Aircraft structures and components can develop electrical potential. Bonding provides a controlled path for electrical charges to equalize and helps prevent unwanted electrical discharges. In fuel system areas, maintaining the correct bonding configuration can be critical. A missing, damaged, incorrectly installed, or improperly secured bonding connection could compromise the intended protection. Another example is wire separation. Aircraft wiring is carefully routed to maintain separation from other wiring and systems where required. This can help protect against electrical interference, short circuits, physical damage, or other potential hazards. A CDCCL may specify a particular configuration that must remain unchanged. That means a maintenance modification cannot simply be made because there appears to be a more convenient route. Fuel tank protection is one of the most important areas where configuration control can matter. Components inside or near fuel tanks are designed with specific characteristics to reduce the possibility of becoming an ignition source. This can involve electrical equipment, connectors, wiring, fuel quantity sensing systems, pumps, and other components. A technician must never assume that a standard replacement part is acceptable simply because it physically fits. So, what should a maintenance technician do? First, identify whether the task involves a CDCCL-controlled configuration. Then, consult the applicable approved maintenance data, such as the Aircraft Maintenance Manual, Component Maintenance Manual, Structural Repair Manual, wiring documentation, or other applicable manufacturer instructions. Follow the specified parts, materials, dimensions, routing, clearances, torque values, and installation requirements. And if the required configuration cannot be achieved, stop and obtain the appropriate engineering or maintenance guidance. CDCCLs are not simply paperwork requirements. They exist because specific design features have been identified as important to maintaining the aircraft's safety. A modification that looks insignificant on the ground can have consequences that are not immediately visible. That is why configuration control is essential throughout the aircraft's entire service life. A good aircraft maintenance professional should never think, "It looks okay, so it must be okay." The correct question is this configuration approved and does it comply with the applicable maintenance data? In aviation, compliance is based on approved technical information, not assumptions. CDCCLs are a critical part of maintaining the aircraft's original safety design. They remind us that some configurations must remain exactly as specified, even after thousands of maintenance actions and years of aircraft operation. So the next time you see a CDCCL requirement in aircraft maintenance documentation, remember one thing. It's not just a limitation. It's a safety barrier designed to protect the aircraft and everyone on board. Follow for more aviation maintenance knowledge.